Hey guys, all right, let's get started. So today we're going to talk about probability of independent events. Okay, probability of independent. Oops. Okay, and what we mean by independent events. Okay, these basically one outcome does not affect the other. Okay, one outcome does not affect the other. Okay, so let's think back to when we did probability. Okay, um, earlier this week. First of all, we find the probability of something, okay, favorable, or what we want, a favorable outcome, over total possible outcomes, right? Okay, so what we're going to do here is we're going to have two separate events, and we're going to find the probability of both of those happening. Okay, and the way we're going to do that is we're going to multiply the chances. Okay, now it sounds complicated, but it's not, I promise. Okay, so let's take a look here. Let's say I want to find okay, let's think of a number cube. Okay, I'm talking about a number cube um, like a die you use in a game. Okay, so a number cube, and let's say that I'm going to flip a coin. Okay, now no matter what I roll, if I do the number cube first, or if I do the coin first, it doesn't really matter. Whatever I roll on this number cube is going to have no effect on what I flip the coin. Okay, doesn't matter what I roll. If I roll a 3, if I roll a 4, roll a 5, doesn't matter. It's not going to affect the probability that I'm going to get a heads or tails on the coin. Okay, so let's say that I have a probability. I want to find the probability, I should say, of rolling a 3. And now this is a key word here. And that means not only does this have to happen, but this second part has to happen too. Last time we saw the word or. Now that meant either one was okay. But here they both have to happen. That's why the probability is going to be a little bit bigger. I mean, less of a chance of it happening. Let's say I want to roll the 3 and um, flip a heads. Okay, what I'm going to do is I'm going to find each independent probability first. Now, remember, first thing I do is I determine the total number of outcomes. Well, how many outcomes are there on a number cube? There's 6 possible. How many 3s do I have? There's only one 3. Don't put a 3 up here because there's only one 3. Okay? How many possible outcomes are there when I flip a coin? 2. And how many of those are heads? Just one. Okay, and remember what I told you is you're gonna take each of these chances and you're gonna multiply them. So all I'm doing here is multiplying these two independent probabilities. 1 times 1 would give me 1. 6 times 2 would give me 12. So I would have a 1 in 12 chance of not only rolling a 3, but in addition to rolling a 3, flipping a heads. Does that make sense? 1 in 12 chance of that happening. Okay? I'm going to write one up here and I want you guys to try it. You guys find the probability of rolling a 5 and let's say I'm going to take you have two number cubes, okay? I want you to find the probability of rolling a 5 and on the second number cube rolling a 2, okay? Now remember, each of these are separate probabilities. They're independent of each other. Whatever I roll on the first one doesn't have anything to do with what I roll on the second one. Even if I'm just rolling one die twice, same thing. How many possible outcomes are there on this first die? There's 6, and how many 5s are there? 1. How many possible outcomes are on the second one? 6, because it's a 6-sided number cube. And how many 2's are there? There's just 1. I'm going to take those and multiply them. 1 times 1 is 1. 6 times 6, 36. I would have a 1 in 36 chance of rolling a 5 and then a 2. Does that make sense? Let's hope so. Okay. Now, let's say I take a coin and I flip a coin 3 times. Okay, now, even if it's only one coin and I flip it 3 times in a row, they're still independent because it doesn't matter what I flip on that first one. It's not going to have any effect on what I get on the second one. Okay, it's not like if I flip a heads, well, the weight distribution is going to be different on the second one, so now I'm more likely to get a heads. Baloney. Okay, so let's say I wanted to find the probability of getting 3 tails in a row. Okay, well, remember, there are how many different probabilities here? There's 3. Okay, so what is the probability of me getting 8 tails on the first one? Well, how many possible outcomes are there? There's 2. And how many of them are tails? 1. Now, the second time I flip a coin, that's the first one. The second time I flip a coin, how many possible outcomes are there? There's 2. And I want it to be a tails. How many tails are there? There's 1. And then I flip it a third time. Well, there's still just 2 outcomes. And how many tails are there? Still 1. So the probability of me flipping all 3 tails in a row, 1 times 1 times 1 is 1. And 2 times 2 is 4, times 2 is 8. So if I take that coin and I flip it 3 times, the probability of all 3 of those being tails is going to be what? 1 out of 8 times. Okay? Hopefully that makes sense, guys. That is independent probability. It's a little bit confusing at first, but I think once you go through these examples, it's actually not that hard at all. Okay? Watch this video as many times as you need to. God bless you, and we will see you soon.